See the next. What is electrostatic conductors? Electrostatics means what? Statics means charges must be at rest. Okay na? Electrostatics conductors. So whenever I am keeping a conductor inside the electric field, what are the properties will be there? Okay na? What kind of effect will be on the conductor if I kept the conductor inside the electric field? Okay, now what is conductor? Conductor is a substance which carries the electrons from one place to another place. But whenever I am keeping this conductor inside the electric field, okay na, what kind of properties will be there? We can study now. Okay na? So here I required what is electric flux, what is electric field. Okay na? So see here. First of all, what is that? Electrostatic conductors. Okay na? What are conductors? Conductor is a substance which carries the electrons from one place to another place. Every metal having their electrons. Okay na? Metals are always a conductors. See here. So, what are the properties of conductors if I kept inside the electric field? Okay na? See here. First one is, if I am consider a conductor, always the charges are reside on the conductor. So, if the charges are reside on the conductor means inside the conductor there will be no electric field. Got the point? Okay na? See here. So, if it is your conductor, whenever I am giving a charge, plus Q charge I am giving to this conductor, always these charges are reside on the conductor itself. These charges may not go inside the conductor. It means that from this we can conclude that the electric field must be zero inside the conductor. What is first property? The electric field is zero inside the conductor. Okay na? It is your first thing. If I kept same conductor in an uniform electric field, okay na? In an uniform electric field, if I kept this conductor, then what may happen here? What may happen means inside the conductor there will be a charge carriers. Okay na? There will be a charge carriers. So whenever I am keeping this conductor inside the uniform electric field, so it is your external electric field. Is or not? It is your external electric field. So inside the conductor induced electric field will generate. Okay na? So induced electric field means inside the conductor there will be a charge carriers. If there will be a charge carrier means, so positive charges are reside on one side and negative charges are reside on another side. So here I am writing this external electric field plus here from these 2 points it is called E induced. So E induced is equal to 0. How E induced must be 0? See here. It is your positive charge. It is your negative charge. Get cancel each other. So like this only. Positive, negative, get cancel each other. Then what happens? So inside the conductor electric field must be is equal to external conductor. Okay na? External electric field. Then what happens? So external electric field plus induced electric field must be 0. So from this we can conclude that inside the conductor the electric charges must be 0. Okay na? Then what is second property? Always, see here, if it is your conductor, the electric field lines are always normal to the surface. Okay na? See here, I am taking, it is your conductor. So electric field lines are always perpendicular to the surface or not? Okay na? See here. So if I taken, just by assumption I am taking, it is your positive charge. Positive charge means always electric field lines are outward. Outward is the sense. These are always perpendicular to the surface. So second one must be the electric field lines must be perpendicular to the surface. Okay na? Then see the third one. So I'll rub this. Then third one will be the potential inside the conductor must be zero. The potential inside the conductor must be zero. Okay na? What I told, the potential must be zero inside the conductor. See here, inside the conductor potential must be zero means, as I told, first property, what I told, electric field must be zero inside the conductor. If there is no electric field, there will be no potential. So see here, it is your conductor. Inside the conductor the electric field is zero. So electric field is zero means, then potential must be zero. We derived an equation, this E is equal to minus dV divided by dr. Okay na? So electric field must be zero means what? It must be zero is equal to minus dV by dr. So integrate it. What we will get? So this V is equal to constant. After integrating, V must be constant, isn't it? So this V must be constant interior of the conductor. So interior of the conductor, the potential must be zero. One more thing, how the potential must be zero? If I want to calculate the potential, I must, what is potential? So this V is equal to Q by T. Okay, sorry, work done by charge, is or not? So this V is equal to, so if there is no external electric field, or else if there is no potential, is there any work? No. If work is zero, potential must be zero. So potential must be depends on what? That is always in work done. Okay na? So like this also we can conclude. Then fourth property will be, see here, it is your fourth property tells us that whatever the excess charges are inside the conductor, that must be in static situation. Okay na? So the excess charges inside the conductor must be in static situation. Okay na? What is the meaning of this? So every charges, there will be charges inside the conductor, but electric field must be zero. Okay na? So whatever the charges are present inside the conductor, so they are in static situation, they may not move. See here, if there is a positive charge as well as negative charge will be there. Okay na? So if there is electric field must be zero. See here, I am checking, it is your positive charge, here will be your negative charge. Okay na? These are in a static situation without giving any electric field, is or not? So ಯಾವುದೇ ಒಂದು ವಸ್ತುವಿಗೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೊಡ್ಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಅವು ಚಾರ್ಜಸ್ ಯಾವಾಗಲೂ ಹೆಂಗಿರುತ್ತೆ? ಸ್ಟ್ಯಾಟಿಕ್ ಮೋಷನ್ ಅಲ್ಲೇ, ಸ್ಟ್ಯಾಟಿಕ್ ಅಲ್ಲೇ ಇರುತ್ತಾ? So these are the very important properties of electrostatic conductor. Then fifth property, what is fifth property? Fifth property is fifth one, the electric field the electric field just outside the irregular conductor, just outside the irregular conductor is E is equal to Q divided by epsilon naught, or else if I write in vector form it will be unit vector n. So the electric field just outside the irregular conductor, okay na? So irregular conductor means what? See here, I am taking, it is your irregular conductor, just outside I want to calculate, okay na? Just outside of this I am taking, here is a conductor of area A, okay na? So just outside of this conductor there will be a positive charges. So outside the conductor means there will be a surface charge density. So as we studied, we derived in applications of Gauss law, okay na? Same derivation we are doing here. So here irregular conductor, I am considering it is your cylinder, there will be positive charges, area must be E. So electric field lines will be along this direction or not? See here, these are electric field lines. So if there is a electric field lines, there must be what? Electric flux. So if there is a electric flux, this portion is taken as what? Gaussian surface. So Gaussian surface means we required Gauss law, electric flux, as well as what? Surface charge density. From this we can conclude this derivation, okay na? Let the electric flux is, what is your electric flux? This pi is equal to E times of A, okay? Let us call this is equation number 1. Then the Gauss law is this, again pi is equal to Q divided by epsilon naught. Let us call equation number 2. Equate equation number 1 and 2. Equate equation number 1 and 2. What we will get? So EA is equal to Q divided by epsilon naught. Is or not? Then let us call this is equation number 3. Then the surface charge density ಸೊ ನಿಮಗೆ ಇದು ಏನಾದರೂ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಒಳಗಡೆ 10th ವಿಡಿಯೋ ಇದೆ, ಓಕೆನಾ? 10th ವಿಡಿಯೋ ಇದೆ, ಅದರೊಳಗಡೆ ಹೇಳಿದ್ದೀನಿ ನೋಡಿ ಇದು ಹೆಂಗ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು, ಓಕೆನಾ? ಸೊ ದಿಸ್ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಸಿಗ್ಮಾ ಈಸ್ ಈಕ್ವಲ್ ಟು charge per unit area, okay na? So charge is equal to what should have? Q is equal to sigma into A. Let us call this is equation number 4. Put the value of Q in equation number 3. Then what we will get? This E times of A is equal to Q means it will be sigma A divided by epsilon naught. So this A get cancels. This E is equal to sigma divided by epsilon naught is the final expression, or else in the vector form this E vector is equal to sigma divided by epsilon naught unit vector n is the final expression. Means what? So this much of the electric field will be there just outside of the electric field, just outside of the irregular conductor, okay na? So last property, that is your electrostatic shielding. So electrostatic shielding means it is the process of protecting the certain region from the electric field, okay na? So last one is electrostatic shielding, okay na? 6th one will be what is electrostatic shielding. What is electrostatic shielding? Electrostatic shielding means to protect a certain cavity from the electric field. See here, I am writing. So electrostatic shielding means it is the process of protecting a certain region of a cavity from the electric field is called electrostatic shielding. Suppose ಈಗ ನೋಡಿ ಇಲ್ಲಿ ನಾನು ಏನ್ ತಗೋತೀನಿ, ಈ ತರ ಯಾವುದೋ ಒಂದು ಇರ್ರೆಗ್ಯುಲರ್ ಕಂಡಕ್ಟರ್ ತಗೋತೀನಿ. ಸೊ ಇದಕ್ಕೆ ನಾನು ಚಾರ್ಜ್ ಕೊಡ್ತಾ ಹೋಗ್ತೀನಿ, ಹೌದಾ? ಸೊ ಸಪೋಸ್ ಆಗಿ ಈ ಚಾರ್ಜಸ್ಗಳು ಈ ಕ್ಯಾವಿಟಿಯಿಂದ ಎಂಟರ್ ಆದ್ರೂ ಕೂಡ ಇನ್ಸೈಡ್ ಒಂದು ರೀಜನ್ ಇರುತ್ತೆ. ಸೊ ಈ ರೀಸನ್ ನಾನು ತಗೊಂಡೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಇದು ಒಂದು ಕ್ಯಾವಿಟಿ, ಓಕೆನಾ? ಸೊ ಈ ಕ್ಯಾವಿಟಿ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ಸೈಡ್ ಆಫ್ ದಿಸ್ ದ ಚಾರ್ಜಸ್ ಮೆ ನಾಟ್ ಗೋ. ಗೊತ್ತಾ ಪಾಯಿಂಟ್? ಓಕೆನಾ? ಸೊ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಶೀಲ್ಡಿಂಗ್ ಅಂತಂದ್ರೆ ಯಾವುದೇ ಒಂದು ರೀಜನ್ ಅದ್ರೊಳಗಡೆ ಯಾವುದೇ ತರಹದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಎಂಟ್ರಿ ಆಗಲ್ಲ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಎಂಟ್ರಿ ಆಗಲ್ಲ ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಅದರೊಳಗಡೆ ಹೋಗಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಝೀರೋ ಇರುತ್ತಾ? ಒನ್ ಥಿಂಗ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡೇ ಝೀರೋ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪೊಟೆನ್ಶಿಯಲ್ ಏನಿರುತ್ತೆ? ಡೆಫಿನೆಟ್ಲಿ ಝೀರೋ ಇರುತ್ತೆ. ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ಲೇ ಝೀರೋ ಇದೆ ಅಂದ ಬಳಿಕ ಮತ್ತೇನು? ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿನೂ ಮಸ್ಟ್ ಝೀರೋ ಇರುತ್ತೆ. ಸೊ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ ಶೀಲ್ಡಿಂಗ್ ಅಂತಂದ್ರೆ ಏನು? ಒಂದು ಸರ್ಟನ್ ರೀಸನ್ ಇರುತ್ತೆ, ಆ ರೀಜಿಯನ್ ಒಳಗಡೆ ಯಾವುದೇ ತರಹದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುವುದಿಲ್ಲ. ಓಕೆನಾ? ನೋಡಿ, ಇದು ಒಂದು ಇಲ್ಲಿ ಇರ್ರೆಗ್ಯುಲರ್. ಸಪೋಸ್ ಆಗಿ ನಾನು ಇಲ್ಲಿ ಎಷ್ಟೊಂದು ಚಾರ್ಜ್ ಪ್ಲಸ್ ಚಾರ್ಜ್ ಕೊಡ್ತಾ ಹೋದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಸೊ ಲಾಸ್ಟಿಗೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿವರೆಗೂ ಬರುತ್ತೆ. ಇವು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ಗಳು ಏನಾಗುತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಅಂತಂದ್ರೆ ಈ ಕ್ಯಾವಿಟಿನ ಎಸ್ಕೇಪ್ ಆಗಿ ಬರ್ಬೋದು. ಇನ್ಸೈಡ್ ಒಂದು ರೀಜನ್ ಇರುತ್ತಲ್ವಾ, ಆ ರೀಜನ್ ಒಳಗಡೆ ಯಾವತ್ತೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ಗಳು ಎಂಟ್ರಿ ಕೊಡಲ್ಲ ಅಂತ ಹೇಳ್ತಾನೆ. ಸೊ ಎಂಟ್ರಿ ಕೊಡಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಏನಿರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮಸ್ಟ್ ಬಿ ಝೀರೋ ಇರುತ್ತಾ. ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ಝೀರೋ ಇರುತ್ತೆ? ಪೊಟೆನ್ಶಿಯಲ್ ಮಸ್ಟ್ ಬಿ ಝೀರೋ ಇರುತ್ತಾ. ನೆಕ್ಸ್ಟ್ ಏನಿರುತ್ತೆ? ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿನೂ ಝೀರೋ ಇರುತ್ತಾ. ಸೊ it is called your electrostatic shielding. Okay, in the next video we will discuss what is dielectric and dielectric constants. Okay, in the next video we will discuss. Thank you.